Okay, no joking now, I'm really getting started. No, I'm really getting started now. So, today we're going to continue the philosophical discussion about high quality code. We're going to talk about some aspects and some fundamentals that were mentioned in the previous time I was here, which was a week ago, I think. We're going to talk about cohesion and coupling and talk about structures and loops and how to write your code very nicely. Most of the stuff we're going to mention here, you guys already know. I mean, I keep mentioning the fact that your code needs to be neat and nice. You already know that variables need to have some meaningful names, that you have to maybe cut it down to as smaller pieces as possible. You know that I've been mentioning it all the time. Try to expose to the world what the world needs to know. So if you're writing a class and you have your methods, try to have your class bring out only what the world needs to know about it. Use interfaces and everything that nobody needs to know what's going on. There should be a black box, but it should also be a black box that another programmer can read and understand. Because, you know, this old Microsoft Visual Studio, I don't remember which version, but Visual Studio used to open with the tip of the day. And I think maybe Visual Studio 6?
6, yes.
Yeah, before the 2000 and something. Before the .NET Visual Studios, they used to open with the tip of the day by default. And there was a screenshot going on in email saying, write your code as if the person who has to inspect your code or debug it is a psycho killer who knows where you live. And that's actually good advice, because living is an important thing in life. So we're going to talk about methods again. We're going to talk about variables, some rules. I mean, again, these rules are principles that you have to, let's say, try to want to keep, but of course there are exceptions, not just code exceptions, which we're also going to see today, but there are exceptions in any rule, and it's really up to you how you make it. And let's say that coupling has to be as loose as possible, but in the real world there is no loose coupling because your classes will not live in space, in void. So it's important to know that these are the rules, but of course it's important to also know that they cannot be kept 100%, but you have to always try to make the best you can to make your code the best. So, let's see if this works. So, we're going to talk about methods again. We're going to see again examples of coupling and cohesion. We're going to talk about variables, how to use them properly. You know already about the naming conventions and how to put them in the right capitals and all that. We'll talk about expressions. I mean, most of these things make a lot of sense, and they don't really need special introduction. I mean, if you write an expression that takes 3 lines of little code and calculations that someone has to start reading and understanding, it's not a good thing. Constants, we're going to talk about flow in loops and condition statements and coding blocks. A little more about exceptions, as I mentioned, about comments and documentation, and a little bit about refactoring and what's good and what's not. So this is going to be mostly theoretical with some examples of bad things and good things, and up to you to stop me whenever you need more clarification. Dobar dan? Mora? Ne. No, I don't. I can tell you how much Bulgarian I know, but then I have to kill you all. So, not a good idea. So let's start with methods and cohesion and coupling that I've already mentioned last time. So why do we need methods? Actually, C# doesn't give you any alternatives. Some languages have blocks which can be in methods, and they have some running block code which is not in methods, but C#, everything is in methods. However, this gives a lot of power for you to cut your code into the right blocks. And many times when you write methods, you need them to be as simple as possible. So if you have a very complex method, it helps to cut it down, to divide it into blocks, into sub-methods, to simplify what it's doing. And we'll see some bad examples of how methods can become complicated. Of course, methods are reusable code. So if you have a method that can produce a square root of a number, then you can use it and reuse it whenever you need. So they are helping to avoid duplications. They give better readability because we know if you're writing it properly, we know what your method is trying to do. Why is it there? So it's important to keep those simple rules. And also there is the black box, which I always mention, and about encapsulation. Don't let the world know what they don't need. If they have a method, let them call the method, and hopefully the method will supply what they need, or will do what they expect. So if we look, for example, at this little line of code, we can quite clearly understand what is expected here. Yeah, we know the class name, which gives us a good understanding of what we're dealing with. And then we have a collection of accounts, and then we have some identifier of a customer or a class of type customer, and then we have a deposit that will make a deposit of 500, whichever units we're talking about. But once we have that, and we have another class or another part of the project that uses our code like this, it should be clear what is going on. But this is abstraction. This is to them, to the user of this method, doesn't need to know how exactly, just expects it to be done. And if things don't go well here, then obviously we have probably a bug. So keep your methods in what they need to do. So just like I mentioned here, this is supposed to make a deposit. Make your methods simple and clear. Don't make them do what is not expected from them, and of course not less than expected from them. I think these rules are fundamental and quite easy to understand. So here we have a method of sum that will summarize an array of integers just by following a simple loop and putting the sum in the loop, applying the summary into a long variable and returning it in the end. Here we have another example, calculate triangle area, and we have here, first of all, we are checking our variables to have valid values, because we cannot have lengths of a triangle which are smaller than 0, and we're calculating in quite a simple mathematical arithmetic way again. So these methods are simple. Their names imply what they do. They do exactly what is expected. They return the value as they are expected, and if there is some kind of problem with the data, there will be an exception that explains what went wrong, and any user of this method will know what he's doing wrong here. But to them, to the users, these are simple, and they just do what people expect them to do. So, of course, on the other hand, if your method doesn't do what is expected, then we have a problem. Many cases will have QA running around your methods, checking what they're doing. Sometimes you have to write your own tests to validate that the method in all kinds of cases is doing what is expected and returning what is expected. So if the method is, of course, if the method is returning the incorrect result, then you have clearly a bug that you have to fix, because this is not good programming, and this is not high quality code. It's just wrong. And if your method is doing the wrong thing, then you have a bug. If your method is accepting incorrect data, for example, a triangle with a negative number representing the length of one of the sides of the triangle, and it doesn't throw an exception, that could also mean something is going on wrong. So you have to think about what it's doing and how it's doing it, and if it has some problem processing the data, it shouldn't just return the wrong thing. This note here actually says that if you have internal methods that are used, if you have some private fields, anything that you process internally in your class, you can process them as you wish, but once you expose something to the outer world and they are sending you wrong data, you should notify them, not just ignore it and try to process in any way. And then we come to the question of cohesion. Methods should do strictly what they're designed to do. So on the other side, if it tries to do too many things which are not, the less relevant they are to each other, then we have a problem. So keep it simple, keep it to the task given, and that's it. So here's a bad example, almost the same as the previous. So this method, again, should calculate the sum and return it. I mean, that's what the user expects. We have the elements here, which are an array. And this method doesn't just calculate the sum as the other one did. It also goes and changes the array in one of the places. Why? I don't know. But maybe it has a reason to do it. In any case, it's not a good thing, because the user of this method doesn't expect any changes in the array unless this method is called calculate sum and put 0 in the and reset the array. In any case, this is not good practice to start changing the variables that are sent to the method, the arguments, unless there are some output variables, or unless it's a return value, or if you start changing things on the value that is given to you, you better have a good reason for that, and you have to probably very well document it in the name of the method, and of course with comments to show why you're doing it. Here is the calculated triangle area. Again, instead, once we have bad data, which is not acceptable for a triangle, we'll just return 0, which is absolutely wrong. Again, there could be a reason for you to return 0 here, and it could say, well, you can put in the comments that this method calculates the triangle area and will return the area, or 0 if at least one of the arguments are. But again, this is not the best behavior. This is not the best behavior, because this is wrong input and we are just returning also wrong output. So cohesion again isolates the fact that the method should do what they're intended to do, not so much more and no less. They have to have a clear intention. Don't do, of course, again, we're repeating the same principles. Several tasks or hard named. If you have a good reason for that, you have to really, really think about it. And that's about it about that. So a few types of cohesion which are acceptable. We have, for example, a functional cohesion. That means that our method is doing something very specific, a small task, a very well-defined task. So here we have a method that will calculate the square root. Here we have a method that will tell us whether a certain character is a digit or a letter. So that's about stretches my limit. Yeah, but that's okay. They are coming, they're asking, and they're always getting a cohesive result. But in this case, this method almost always returns false. So functional cohesion gives us a very narrow, independent, functional little black box that does one specific task, and that's it. And that's the most compact version, and probably the best one. Then we have a sequential cohesion. A method can do actually a complex things, and for example, if we want a method to send an email, we can follow a sequence of actions, and it will follow them one by one, and we'll do it. But still, for the user of this method, for example, it is clear what we're expecting to send it, what it expects to do. And even though inside, again, it's a black box effect that we don't really know what it's going to do and how it's going to send the email. Of course, all these are also complex actions. So connect to mail server is something that is not trivial. Could be also broken down to several actions. How do we connect to the mail server? Where do we get the address of the mail server? And which way do we connect to it? Which libraries do we use? And so on and so forth. So each one of those is also an action, but what we're getting in the end is quite a complex method, but still quite clear what it's doing and how it's doing it. So we have a sequence of operations which are related to our main goal. So that's also fine. And then we have another type. Once we have some kind of data processing, which is also common. So this method is also some kind of a complex sequence of actions which are related to each other in a way, but in the end they're all built to satisfy a specific task, so it's still understandable what we're doing here and what is the expected result. So this method is actually a subroutine that does some kind of action for us, and that's okay too. Sometimes we need some methods to correspond with certain events or time or schedule. So again, we know what is expected here, and we know when this is expected to be done. These are very common scenarios whenever you're building a Windows or a web application. So we have methods which are their task definition is time dependent and not just functional dependent whenever we need them. They will sometimes be triggered automatically, sometimes by the user, sometimes by a scheduler, sometimes by a service, but still the definition of what is happening and who is trying to do and what is still kept in the clear. A bad example is when your method is trying to do tasks which could be related to each other, but they are separate tasks which are completely different from each other. Of course, there is a reason, there are reasons to write a method that will process the input and act according to it in different ways, but this should be kept to minimum. So in this case we have read, which we are sending an operation code, and first of all the name here is bad, and second we act completely different on different values, which is not bad, not good. And yeah, the worst of the worst, the spaghetti. Yeah, this could work only. There used to be a restaurant here called Spaghetti Company. Yeah, maybe there it could be nice. So handle stuff is not a very good name, and nobody can guess what this method is supposed to do. It gets all kinds of data from all types, and it handles the stuff. This could go well for Mutra. They'll handle the stuff. Don't worry. Yes. Just send it whatever, it will handle it.
Some magic.
It's a magic. By the way, the word magic, I've encountered it quite a few times in Telerik. Not in a bad sense, just in some ways that you have methods that are so complex that, well, it's magic. It works. No. Yeah. But yeah, you do encounter complexity of methods which are almost magical sometimes. So coupling is the other side. Not just that your methods are very task-oriented to what they're supposed to be doing, but also how much they interact with the outer world, and how much your methods depend on other methods, on other classes. And of course, again, your classes don't live in a void, and if you have a big project, it's always a good idea to cut it down into classes and into methods, and they will obviously interact with each other in most cases, but try to minimize the dependency, especially of members to external members. So if my class has to process something which is given by another class, let them affect each other's members as little as possible. Not so much, because in inheritance, once we have a case of inheritance, these classes are related to each other in a very tight way, and many times you have members which are defined in the base class that you have to address in your inheriting class. And besides, once you have inheritance, well, first of all, many times you have to use the same because they are the same, and many times there is, as we've seen in polymorphism, we address the object as a base class, and actually what we're holding in our hand is an instance of the inheriting class, the deriving class. So in many cases in inheritance, these things are they are not separate classes. They should not be decoupled. They are, in many cases, treated as the same class almost. But once you have two classes which are two different entities, like, I don't know, employee and company, or employee and bank account, things which are supposed to have, they have to know about each other, because in many cases they do interact with each other, but keep them as separate as possible, knowing at least about each other, not affecting each other, and not going to each other's private parts or even public parts and just meddling with them. That's the idea. Of course, coupling is much. If we're talking about cohesion, it's a much more. It's a task which is much easier to achieve, but coupling will always be there. You just have to keep it loose as possible.
What are side effects?
I think that the meaning here is that you are modifying parts which are not yours, that you are making changes in classes which you shouldn't. At least That's my understanding, because it was noted in the previous slide as a side effect when we are changing the array. When someone sends an array, and we're just changing it.
Some node. We get one
Node.
class node. It's a bar. Doesn't matter.
Mhm.
It's a function. And then we have several classes which are interacting with these nodes.
Mhm.
The same class. For example, our groups, our friend gets the same class.
Mm-hmm.
And they all are interacting with this node. They cannot inherit one of these classes because we can inherit only one.
Well, one thing.
Other way also, it cannot be parameters from the other classes because it doesn't need all the information. Which
Yes.
is
Okay, many times, that's a good question. Many times your class should maintain its own functionality. So that if you are holding a class of an employee or a person or whatever, and it has some related actions to be taken, or some manipulations or modifications, in many cases it's good for the class to know in itself how to act. Like if we have the dog class should know how to walk. But if it's inheriting from an animal and we have other animals, they should also know how to implement their own functionality in their own way. Once you have two classes, and one of them is a data structure, let's say an object which holds data about a person, and then you have another class that starts interacting with this class, or making functionality which is actually directly related to this person class, for example. You should keep this interaction between them to minimum. If the class can be as self-contained as possible and modify its own data when it needs to, that's the best. If you really need another class to start interacting in a way that it makes changes in your class or acts on your class, that should be kept to a minimum. Usually, as an external class will call your class methods, or will address your public properties, and we'll also mention fields, but fields should be, the actual data which is stored in your class should be encapsulated, it should be private in most cases, and you should have properties, public properties, which manage the access to your field. So when somebody goes to your property and assigns a value, you are catching this assignment and you do your own functionality. You can check the value, you can throw an exception, you can populate your own. This is up to you, but interaction should be maintained to an interface level between classes. And whatever your class can do for itself, let it do. Don't let other classes, for example, if you have the dog class, you can't have another class that will make the walk action by going directly to your class and doing things. So keep the interaction to a minimum. That's
you have to rewrite the walk action to all the dogs, to cats, to properties.
then you
have to rewrite walk with just one.
then put it in a base class. Whatever is common. Yeah, common functionality. Then you come to the idea of inheritance and how you plan and design your hierarchy of classes. If you have common functionality and they are obviously classes which relate to each other in what they expose in it, then they should either support the same interface or inherit from base class, a common base class, or probably some abstract base class, and then they can implement their own. So that's again, but once you have an object, it should be as self-contained as possible. And well, you can. In many cases, your object will be a member of another class. So if you have a class of an employee and a class of a company, they could be they could be members of each other. So it could be that the company has a collection of employees, or if you have a person, it could have a field which is a company, which is a company class. So these relations are also okay. But again, even in this relation, when they are members of each other, they should still know to keep their own self-contained and not to start being manipulated by external classes, just unless you have a good reason for that. Keep them in their own world. That's as much as possible. Once you have tight coupling, which is too tight, you're starting to have code which comes from here. Actually, I'm calling a method in there. I'm changing a member of another class. Hello. Привет. C#. It's me.
Coupling is loose enough. I mean, we could make was totally independent from all of the others, but we will re-implement the logic from this class. Then we are blocking the application of this class.
Yeah, classes need to know about each other. Classes obviously need to know about each other, but no, as little as possible meddle with each other's data and be as self-contained with their functions again. They will always know about each other. You can't have, because if you are completely losing the coupling completely, then each class will be a full program to implement the whole functionality that you need. But then you lose the idea of classification. So make your classes self-contained. Think about what they need to show to the world, and also if they do show something to the world that the world can use, make sure that the other class doesn't exploit that. So that's the basic idea. Coupling will always be there because classes in your project will know about each other. But keep it as loose as possible.
This is the idea of properties.
Hmm?
This is the basic idea of properties. That's why
Properties, encapsulation, polymorphism, all the tools of object-oriented design are there to keep your classes separate and self-contained. And the whole idea of classes in general is this. So, did we see this one? Ideal coupling. Methods depend only on their parameters. They are not doing anything outside what they have as data. So, again, a method should be, as we've seen in the good examples, should be clear what they're doing, receive the data, do what they expect, put the output that they're expecting, and that's it. Not starting to meddle with each other, knowing too much about other classes, changing the data. Just keep them in their own world. Of course, as I mentioned, in the real world, coupling will always be there. You cannot avoid classes from knowing about each other, but make it as loose as possible. And sometimes you need to tighten the coupling. Sometimes you need to tighten the coupling a little bit in order to make your code more readable. So there's this quite a bit complex example of an encryption method that gets a byte array of some data and some secret key and runs some procedures to encrypt this data. If we compare this code with a more compact code, actually what we're doing here, we are doing some work which is a little bit coupled, because we are doing some of the work of the actual encryption inside here. We're creating objects and we are doing some of the work directly with classes. We could separate the procedures into external methods, and this could be in a complex algorithm, could be more difficult sometimes to follow than this, to follow and debug, especially if we're talking about real complex algorithms. So again, this is up to you how you set your classes and how much they know and how much they interact with each other. So here's a bad idea, a bad example, but actually I'm not fully agreeing that this is such a bad example. We have the class here, the Sumato, and it has two public integers, and it returns the sum of these integers. It's written badly. Yeah, it's working on members of the class, and in many cases you'll have a class which has members which are data holders, data containers, and some of the methods or properties will have to return processed information. So in this sense, this is not the worst example I could think about it.
I think because the variables are public.
Yeah, first of all, these are not written as properties. These are like public fields, and that's first of all a bad idea, because you're exposing them. And once you have an instance of this class, let's ignore the fact that our main static method is also here, which is using this class in itself, because this should have been a separate class that is separate from our main application method. But let's say that they are in separate classes. We have here the publics, which we have only a default constructor here, so we cannot. Well, we don't have a constructor at all. So we have an implicit default constructor, which we are using here, and we are going and just setting the data of these publics. So anyone can go to these public parts and change them as they will. This class has no management of its own data, and the only thing it can know is just return the sum of these numbers. It's bad because this is not the way to have a class and then set the variables and then call a method. That's quite ugly. Yeah.
We should thinking about actions of class which is happening somehow that domain in this case.
Mm-hmm.
What about this class? If we can several actions which are different procedures depending on what kind of thing is happening in our program, how we are separating. For example, if you just you have to do something, but if you are just covering
Uh-huh.
over, then you can do something else.
Okay.
These are different actions.
Yeah.
We are creating different classes for them, or we just keep
No, they
class
will-
which is holding those?
No, when you are reacting to different actions in different ways, the relation is usually to the object that you are interacting with. So if we go for a simple example to the console, which is most of the applications so far, then the console is the one that we're interacting with, and we can read data and write data to the console in the same code in different ways. But if we're talking about more complex, for example, a button or a link, then the button or the link is the object you're interacting with. And, well, if we're talking about more complex parts of the program, those will expose events. And your program can interact with those events. But they're still exposed by the object, which is your link in this case, or a button, or whatever. And your program will. That's a bit of a coupling indeed, because you are building handlers to different events, which will behave differently, but that will usually be wrapped in, again, in the context of your runtime. either a form, which is holding this button, which manages the interaction with this button.
I mean, here I understand it differently. For example, if you are talking about the console, I think that you should have a class which is reading,
Mm-hmm.
and doing all the actions in this console.
Mm-hmm.
We don't need to, the class which is writing itself on the console, we don't need it. We shouldn't have this kind of class, which is writing by, if it's his job to write his job on the console, then let him do it. But if his job to make a song, for example, it shouldn't write this song on the console.
Okay, let's talk about the console, for example, as an example. Most console applications are very simple task applications that you are running an executable and it's supposed to do something. Print something, type something, copy something, display something. They're usually task-oriented executables. And then you have more complex console applications, if, for example, a game that you can build. And you can have a method that will manage your menu. But this can be separate, the menu handler in one class. It could be one task. Once we have separate tasks that we're interacting in different ways, we have to start separating them aside, either to different methods or maybe encapsulate them in separate classes. So again, break down your code as you see right. But I don't think that there should be a class only for writing and a class only for reading, for example. It should be some kind of context oriented to what you're doing at the moment or what's your task. So here I don't like the fact that main is in the same class of our utility class. It's okay that you have members and you have a method that returns some kind of processed data. It's not okay that these are not related. It would be much better if this method could receive arguments in this case, or that we have some kind of better interaction with the other methods, like setting a variable and then setting them through some public properties which are storing them in fields, and then we can process the output here. It's just not nice that you have to first call the constructor, then populate the things, and then calculate the sum yourself. It could be better if we had a constructor with arguments and return a value, or a method with arguments, whichever way, just not put them completely depending on actions that are not. So again, all the principles, all the philosophical principles of object-oriented programming that we've been talking about are valid for making your coupling as loose as possible. Make sure that there is abstractions, classes know only what they need to know, encapsulation, so you have black boxes. Don't let the world meddle with what they don't need to. That's also part of the way you design your classes. If you want to achieve better coupling, looser coupling, make sure that your classes stay in their own world as much as possible. Whoever needs something will get it visible as much as they need. Methods. Once you have a method, make sure that the method behaves properly with its parameters, and that's it. Not starting to do whatever. And we have some examples of what to do and what not to do. So if your method is depending on the class fields, that's okay. If your method is depending on some static methods, that's also okay, because static methods are usually meant to be project-wide accessible. Once you start relating your method to fields, then that's a problem. For example, here we had those are actually public fields. They're not properties, and that's not good. So yeah, fields are the most to be kept as little as possible. I think we're just repeating more. Parameters. So methods, it's good to couple your methods with the parameters. Once it does what it needs to do, you have the parameters, and okay. Okay. The important parameters are coming first. That's a good idea. Also, in many cases, we'll have parameters which are mandatory coming first, and then we can have parameters with default values. We can have optional parameters. We can have overloads. So, for example, we can call register users. We can have different overloads of this method with different number of parameters, and they can feed each other once we're not supplying what is not needed. But usually those will be coming last. The optional ones, the default ones, the ones that are less important to populate, usually coming last. Don't modify unless somebody expects it. So if you need to change the username to lowercase so you can check it against your database, do it in your own variable. Don't change someone else's work. It's not nice.
This is also about reference objects?
Yes, especially about reference objects, because if they are reference objects, you are really changing them. In some cases, we have methods which return output parameters as well as a return value. That's okay, because the user knows that they are output parameters, and they are expecting some returning value there. They are expecting something.
But all the methods like sort, like search, there are some kinds of more types.
Yes, but those would usually be, again, encapsulated in the class itself. If you have an array.sort, it's not like you're saying sort algorithms.sort, and then you send an array and this array is being returned. This array is being changed. I mean, let me open Visual Studio for a second, or Notepad. So that's a so if you have a class, you have my array, that's okay, because I'm doing it in my own world. But if I have some array utils, that's already not so nice, because this method returns, if this method changes the array, then we have a problem. It would be better if it changes the array and returns a value, or, for example, yeah, it could be a Boolean. If it managed to sort it, but in any case, usually we would say we're sending an array and we're receiving a sorted array in an output variable, for example. So this, unless you have a good reason to do it like this, unless it's self-contained, so the class knows in itself what it needs to do and how to do it with its own objects, so that's okay. This, when you are taking something and just changing it, let's say this method doesn't return a value, but it changes the array, it's borderline, let's say, if it's a sort, because it's obvious what it needs to do, but not the best, not the most beautiful way to do it. So if you need to make changes, don't change the user's arguments. If you have methods which are related to each other or overriding each other, make sure that the make sure that the arguments are kept in the same order, the same name, so that they can be well, that the user can have some kind of logic and keep some consistency. And copy paste, yeah. Copy paste helps a lot to keep your code consistent. If you have output parameters, put them last. That's usually a good convention too. Okay, sometimes we need to pass to a method an object, for example, a full employee. And sometimes we need to pass just some data, specific data. That depends on you, how much of your data is needed for the function. If this function does a very specific calculation on some integer value and it doesn't need the whole employee object, many times it's good to send only what it needs. So if you have an employee and it needs only if you need only one field out of this class, then maybe it's not so good to send the whole thing. So keep your methods also on exactly what they need to receive. Seven parameters limit. Okay, this rule is a bit difficult to maintain in many cases, but if you need more than 7 plus minus 2, let's say more than 9 parameters for a method, then have to rethink. Although there are, especially in older code, if anybody has been working with Windows API or working with some even MFC libraries, there were some terrible methods that receive a lot of parameters. Yeah. And sometimes you need methods to receive a lot of data. I don't know why 7 is a magic number in psychology. I don't think the human brain should start processing each and every parameter. But if you have a method which is well documented and it knows what it needs to do, and each of the parameters is justified to be there, then it's okay. And if you're writing the code, it's okay for your parameters to be also in multi-line. So if you're, let's say, a method with a nice name, do something, let's make it private so we're in good practice. And once you start putting arguments, which are too many, you can start breaking them into separate lines. In many cases it will give higher readability, and so on. And in many cases there are methods like this which are big with large names and many parameters. So the 7 arguments rule is good to keep if you can, but it's one of the rules that is difficult. And if you see too many, it's really something to consider. Maybe you need to encapsulate those in some class. How big should a method be? I know about an old rule that says that a method should always match your screen and not to be much longer than what the user can see in one shot. Of course, it never happens, and complex methods are becoming quite big. Of course, long and complicated methods are always bad, but it's, again, one of the rules which is difficult to maintain, especially in the real world. Many examples are complex. Variables. How are we with the time? Okay. And how are we with the slides? Okay. Yeah. So in many cases, you will see statements like this. Once we're returning a value which is calculated directly, it's especially useful for very short and simple methods which are doing very simple tasks. Of course, it's always a better idea to put it into a variable and return a variable, but personally I would merge these two lines into one. It's easier to debug because you can put a breakpoint and you can see your value before it's returned. I think that in Visual Studio 2012 they're going to add an option to see the returned value of a method even if it's written like this. But I'm usually trying to allocate as few possible variables if I don't need them or if they are overlapping. But again, this rule is up to you. Variables better be initialized unless you have, again, a good reason not to, but there's never such a reason. So once you're declaring a variable, make sure it's initialized, so in every part of the code, whoever looks at it, whoever debugs it, will know what the value is. And in many of those cases, you'll have compilation warnings, and some developers think that warnings are okay. If you have your code compiled, it better be with 0 errors and 0 warnings. And many times those warnings come to help. Know that, of course, in our Sitefinity projects we have many warnings in the code, but it's inevitable.
I remember that.
You do?
Yeah,
yeah, but these are code analysis warning, not build warnings. But we have many of those too. So that depends. Null is not such a dangerous value. I mean, if you're not initializing a variable, it will hold null in many cases. So it's better not to have lines like this in any case. So don't put just a variable with no initialization. It's not a healthy practice. So even though variables are automatically initialized with their defaults, as it says, you'll get the warning, but don't leave them uninitialized unless you really need to, but you never really need to. So here we have a class of a student, and we have some private fields. And again, your class will run into trouble once you have data which is not initialized. It can be. I think that the worst that can happen is that computers will start killing people. And that's because at that point they will become unpredictable, and unpredictability is dangerous. So I think that also in your code you should avoid unpredictability as much as possible. If you have variables, make sure that at any point in time in your code they have some specific value of some kind.
Is it bad practice if we initialize the variables of the class when we declare them?
You can use
if we don't do the constructor, is it bad or?
Unless you have a reason. I mean, the good thing is that the constructor will initialize. Still, when you're declaring a variable, it's better to have it initialized, and a constructor can override whatever it needs, or usually the constructor will receive some external data and then it will populate the private fields, overriding them. But still, you can have several constructors that do it in different ways, and again, it's always a fallback option when you have fields like this to first make sure they are initialized somehow.
What if the class is abstract? Because then you cannot make an
still, you can. I think they could be declared in an initialized way. I mean, an abstract class can behave like a regular class, except that you can't instantiate it. The variable scope. Again, the rule: keep your variables as least famous as possible. Let the world know about them only if they need, and usually do it through a property or a method if somebody needs to access some data in your class. So we have all the accessor modifiers. We have the static, which just puts your variable on a class-wide publishing, and then we have those accessors which go from the most famous to the least famous. We go from public to the protected to the internal to the private, and always make sure your variables are least famous as, I'm not sure famous is the nice word here, but least accessible as they need to be. Because again, once other classes start meddling with your variables, then you get some bad couplings. Here we have two classes, and we have a public static integer, and we have a different class which starts setting the global states. So these things maybe shouldn't be separated in this way. Once you have some global variable, even if it's relating to your class, it better be a member of your class. Such global statuses are usually not good to maintain, and if they are, they better be well made and well required. So these classes are too much depending and too much interacting with each other's variables. And then we have those two parameters about the variable, the span and the lifetime, and they both relate to the number of lines in which the variable is used. The idea here is once you declare a variable, put it in the smallest possible footprint in your code. Once it's there, put it as close as possible to where it needs to be used. And if possible, make sure that this first one, the span, that means how many lines of code between usages are set to minimum, so that you are not declaring a variable and then 50 lines later you're starting to use it, or 50 lines later and then another 50 lines. If you need, just keep them as tight as possible on where you need them. That increases the readability of your code significantly. So here we have the count variable, which is declared here, and we are using it here and here. So we have a long lifetime of this variable, and it spans on average almost 5 lines each time that we're using it. So in many cases this is okay, this code is acceptable, but once you start putting variables and then addressing them in far down lines, it could reduce the readability, and also it's better practice to keep it tight. So for example, we're declaring it down here and we're using it only in this part of the code, and in that way we're keeping it more tight to where it's needed. Of course, in many cases, for example, these numbers are used here and here and here and all the way down, but take your span of where you're using your variables as tight as possible. That will be better. Just like method, what? Variables, just like methods, just like any other part of your code, should be a single purpose, a single task kind of containers, so that, of course, their name should be very clear to what they're holding and what they're for, and they should always contain the data that are expected to contain. So students count or average grade is not a good name. Even when it's clear when they contain which. Don't define variables that are not used. Well, this is not a big problem in your code. Of course, it will run. You'll get warnings about that. And if you use some extensions, it will also mark the variables that you're not using, also methods that you're not using. And, well, that's pretty much self-explanatory. If you're defining a variable, make sure that you're using it. If it's not used, maybe it shouldn't be part of your program. Again, magic in your code. Don't define variables with unknown intention. So, for example, when we're holding an integer variable here, which has a number which relates to a specific file mode, for example, these things are hard to read, to understand what they are relating to. It's much better to use enumerations that give much better readability and much hard typing. Always use enumerations when you are in such cases. Don't start running numbers which are meaningless to most people. Okay. Expressions. Again, keep your code as simple as possible. That means breaking down parts of the code as much as possible. So if we look at this expression, it's very tough to start understanding. Some parts of the code are difficult to read. For example, if you're using regular expressions, which can be quite deadly. But if we're talking about expressions, also any expression that you're putting in your code, make sure it's as little as possible, as readable as possible, and if you really have to create such a huge thing, make sure it's broken down. So here's a better way. Break it down. This is much more readable, much more debuggable. We know what we're doing. We're calculating indexes first, then we're using them in coordinates in one array and then in the other, and then we're what exactly we're doing. Some developers like to write like this because it's much more compact and less lines and less variables, but personally I don't think it's good. So keep it simple. Even if it's complicated, keep it simple.
It's the same for the if statement.
Yes, it is the same. And,
Because in if statements you can avoid some of the statements sometimes. Because no, when you get n, if the first one is false, then the other one are not calculated.
yes. Well, with if statements, it's up to you how you simplify what you're doing. Because if statements behave differently when they are in one big expression or when you are putting them nested into each other, and you have to know which of the cases you're not going to be using. So if statement is more about the structure of your code more.
If you have the if statements, for example, 4 different conditions, you can define this condition with bool variables and then check this.
Yes.
But then, if you know that all the statements should be true in order to execute the command in the statement, why if you have to define variables when even if the first one is false, then you don't have to calculate.
That's true. That's true, but the idea here is that we are taking expression, and your if statement could have something like this in one of its conditions, or it can have some. I mean, once your conditions become too complex, you have to break them down, maybe into separate lines. Maybe if it is so complicated, put it maybe in a different method that will calculate this big expression for you, or putting it in a variable. Let's say maybe it's something that you don't really have to do every time, just because to save the variable space. But if statements can become very confusing as well and very big, so break it down as much as possible. You don't need to put variables, but many times you just take the code of the if and put it in some method that will return true or false to you, and then the second part in a different method, and so on and so forth, because it makes it much more readable. Just today I created a small, I had to fix some bug, and I created a big if statement with about 3 or 4 parts, and after writing it, I just refactored it into a method which was much clearer of what it has to return. In this method, I just returned the same expression, broken into lines. And many times when you have, for example, an if statement, which is complex with a lot of ands and ors and things like that, sometimes you have to see what is the case when this expression, this whole thing is true, and then you have to think about what happens when this whole block is false. So if you have a method that calculates it for you and returns a boolean of this whole expression, you can easily say whether this method returns true or false without starting to go into the logics of, oh, I'm changing this to false, so this should be not equals and thus equal, and then it's or, and just put it in one method that returns true or false, and then you can say, okay, this returns true, this returns false. I can easily navigate through the options. Yes, you have to send them. They are in the same class most cases, of course. I told you this sleazy joke about about the program students, where one of the students, programming students, when one of the students comes to the girl and says, and grabs her boobs, and she says, "Oh, that's private." And he says, "Oh, I thought we were in the same class." So, next. Constants are very useful tools. Again, don't use magic number values. In many cases, if I write 3.14, it will be obvious that I'm using pi or p, whichever way it's pronounced correctly. But avoid using numbers which can be not understandable to the reader of your code. So if you put in your code 1024, nobody will know what it really... Well, they will know in the end, but to help your readers not want to kill you, many times it's good to use constant that will hold your values. If those values are important to be numeric, let them have some meaningful consts, which are basically like variables, just that they are values that never change, never be expecting to change, but they make your code much more acceptable. So I think that's quite self-explanatory, right? When we use constants, whenever we have obvious values that we want to increase the readability of the code, and also reusability. So for example, if we have such an expression, we can keep it as a constant instead of retyping it and recalculating it, even though it's just calculated and stored the same way. It's much better. Also, when we are reusing constant values, and we're using, just like we're using variables to hold values, wherever we're putting in a code a reference to a constant value, and then if we have to change something, we just go to a single place and change it, and every reference to this number will now be with the updated value. Of course not in runtime, it's because they are consts, but if we have to make modifications, or let's say that the buffer size now is not exactly this, and if we use the numbers everywhere we need it, we have to go to all the places. It will be hard to find. References to a variable are much easier to find, and one little change and whole code is already up to date. Sometimes it's better to keep the magic values. Well, I think that it's very rare cases where you're using numbers directly in the code. Although I think Microsoft likes returning error codes with numbers that mean nothing, but that's not good practice. And okay, this comment here is a little bit far, but when you're, for example, when you're building an application which is supposed to support multiple languages, internationalization or localization, it's better to have your texts and strings stored in some resource file that will hold them for separate languages. There's a whole methodology about that. I think even, no, I don't think I know that. One of my blog posts covers usage of resource files for an internationalized WPF application. So this comment is really, I think, a little far for our usage now. But yeah, if you have to start storing strings, many strings which are supposed to be more dynamic, it's better to put them in resource files than in constants. But that's pretty understandable. control structures. Many times you'll find code blocks which are single statement, which are not using the curly braces. That's okay, although it's always much more readable when they are used. If we look at this code, it could be quite confusing because we have the indentation. So these two can look at first glance as if they are both parts of the if statement, although to the trained eye it will never seem like that. It will just seem like ugly indentation, but it's always, let's say, better practice even if you have a single statement, to put it in curly braces, just for better readability and division of the code. Here's the if conditions. So again, once you have something like this, which personally I haven't really seen something like this, but first of all I would put them in separate brackets. So we have multiple conditions here. I would first start separating them into separate brackets, and maybe even cutting them into separate lines, so it's much more easy to understand what's going on and which are the conditions here. Once you have something which becomes too complex, like I mentioned, it's better to either store them in a variable or sometimes just call a separate method that will return the right calculated expression for you. Also, notice that if you are debugging this thing and something here goes wrong in this if statement, finding which of these statements caused the fault will be a nightmare. So that's a problem. And one more thing which is not mentioned here, I think, is also the fact that you can make changes in variables within Boolean statements, and of course it's not really recommended. I can put a variable here and put a ++ sign after that and change its value during the if statement, which is something shouldn't be done. So keep it simple, keep it cut down, keep it broken down as much as possible, and I think we already all understand.
I was doing it in try pass.
What about try parse?
If try pass, if you
Yeah, okay, but that's a return value.
and then you give an out.
Okay, but you are first of all, this return value is directly connected to your output parameter, so that if the try parse returns false, then you will know that you don't have valid data in your output parameter. So you can control the flow of your. I mean, this is not a simple case. The try parse is not a simple case, but it's as good as it can be in this case, I guess, because you get information about. Very much depends. In many cases, you are checking the if of the try parse to know that it didn't fail. And if it did fail, you need to, let's say, throw an exception or do something, but your flow will not be continuous. In many cases, you will not be reusing this value of, you'll just have a code block that says if it failed and if it succeed, if we have a success, and that's it. You will not need more usage of this value except in these two if blocks. I mean, in one if block and one else block, and that's it.
So you don't need a variable.
You don't need. You can put it as, if it's really something that you need for better readability and you think it will be better for the user who comes to debug your code, or even if it's you can put it as some variable and say, give it some meaningful name to understand why we're doing it or what we're trying to achieve. That's okay. But many cases, not really required in this case. So we have refactored example of the previous if statement, just breaking it down into variables. Again, these variables are quite complex expressions on their own. Let's say they could be put in their own methods, in many cases broken down even more. But once we see this if statement, it's much more clear what's going on. And before we reach it, we will get errors. We can check them here or here. And if you break it down even more in debugging, you will see much more information of what's going on. Nesting. How are we doing? Okay. I think it goes without saying that nesting too much code like this, going deeper and deeper, is something that can harm the readability of your code. Although, again, all these rules have exceptions, and if you think that you're in a way that you cannot avoid it, then it's probably okay. But these nested conditions are pretty deep going, which makes debugging here a bit problematic, and we are jumping from one block to another, and then we're jumping into another block, and then into another, and then jumping into another, and jumping out, and the readability here is very low. And in many cases, it's better to break it down into separate code blocks, into separate methods, into separate, much more readable, modular, smaller pieces which are easier to follow, and then put them together in a much more readable way. Case statements. I think we're gonna take a short break soon. What's the body count? 60. Oh, 2/3.
It's nice speed.
No, because I think that these slides are pretty much self-explanatory, and if you write code, when you start nesting things or putting like huge if expressions, then if you don't know you have a problem, then you have a problem. So these things I think are pretty simple and pretty logical, and there's not much to say about them, and I keep repeating the same principles of dividing your things, cut them down, keep them on what they need to know, keep the coupling loose. It's just that I don't find much of repeating, but as you can see, I get questions, so if you have something, we'll stop, but we'll keep the pace. You cannot avoid things. These options in the code are there for you to use them. You can create 100 nested pieces of the code if you have no other way to implement it. But it's really up to you. There are infinite ways to write your code, to solve what you need, and it's up to you. And I think in many cases that's why we have architecture. I mean, in many cases we're not working in void, and when we have something new to implement, when we have a new project, when we have new classes to implement, the first thing is to design what we're going to need and how we're going to cut it down. And in many cases we have software architects who take part in the design, in the first design of the code, and you will try to think how you're going to build it in the best way. Then when you come to the implementation, it's really up to you how you break it down and how deep your expressions are going to go, and how you can keep it more readable or more stable or more, let's say, bulletproof. So in many cases, it's really up to you, and sometimes you can't avoid overriding these rules.
Is there something like everybody saying your code is bad? And Your code is there, even if you are coding
Well, sometimes, yeah, the rules are, I mean, these rules cannot be followed one-to-one. They come here to give you guidelines on how it's better to code. And as you can see, when you see a code that looks like this, you can immediately say, well, I would actually do it in a better way, much more modular and structural.
then I can find people that will
Yes, of course. This is almost also an endless process. But that's why also in many cases when we're working on code on a big project, we'll have code reviews. So many times when you come to commit some changes in the code, you'll have someone sitting with you and reviewing your changes and saying, oh, actually, things that you might even haven't noticed when you wrote your code. You say, oh, but this block could be refactored in a better way, or why are you doing this? This variable doesn't actually need to be declared, or maybe it's better to declare a variable. So these rules are really in the eye of the beholder, and as you progress as a programmer, you will become more and more experienced and see more and more code, and you will get more and more used to writing proper code. But even if you do, there are many ways that someone comes, or a team leader or someone sits with you and says, oh, actually this could be better refactored. This is endless. The process is endless. These are guidelines. Of course, they're never kept. You can always get into some condition where you have to do it like this or like that. And just have to do your best to make sure that your code is readable, cohesive, decoupled, and well read and well structured. That's the idea. So case statements, just like any other conditional blocks, I think it's already been discussed. Put them by the frequency, so the most common cases should be coming first, because case and switch case statements go sequentially by the order, and the first time they encounter the case that they are requiring, they will run the code and then break out. It goes without saying that if you have custom special complex logics, put it in separate methods. That goes for every part of the code. And I'm not sure about alphabetically or numerical ordering of cases. I think that's not always the best way. So here we have a case which goes into an if statement, and then an else, and I mean, this code could be a little more readable if we break it down into much more smaller bits of implementation, much more clean, much more neat. We know what happens here, where we're going, and what we're doing. You wanna take a quick break for refreshing yourselves? Let's take a quick break before we continue with loops. So the rules about loops are pretty much like any other rules that we've discussed just now. There are more than one ways to implement loops, and you have to think about what's the right way for you. For example, when you have a collection of some kind and you have to traverse through it, you'll usually use the for each, but not always. In some cases, you'll have to use for loops. In some cases, you have to scan the collection from the last object to the first. So many times you have to keep some kind of index running through the collection so that you'll have some numeric reference to where you are. So in this case, for loops are better. And then you have the while and the do while that can run forever. Also, for loops can run forever too, but while and do while are more intuitive for these kinds of cases. Or then you have to think if it's a while or a do while, because while first checks the condition and do while first runs and then checks the condition. So you have to choose your weapon wisely, which loop you're going to use and why. Nesting loops is also something which is many times not avoidable, especially if you're running through a matrix scan, for example. But if you can break it down to the most simple possible structure, just like in other cases, it's also good to do it with loops. Keep it simple is always the rule, and keep black boxes everywhere. That's always the rule as well. So in many cases you will have some code running here which is not always the most best explained one, but keep it as much as possible readable. Yeah, the American army is very defensive, not attacking. So what is defensive programming? Defensive programming means keep yourself covered. That means that expect the unexpected. Always make sure that your code behaves the proper way, not only in the trivial cases, but also if you have to expect all kinds of cases. In many ways, testing and writing tests will help you keep your codes intact and trying to test all kinds of cases. Always go to consider the unusual situations, because users are unusual and they will always come up with something that will break your code. So always expect all the possible scenarios on your methods, on your classes, on your functions. Go through and put expectations and throw exceptions properly. Check all possible cases first. Of course, exceptions are people too. They need the right attitude as well. So, in many cases, it's better to throw a file not found exception than to throw an exception that says file not found or error or file error. So you can create your own exception classes if you need to, and you can choose from many built-in exception classes. Just make sure you use the right one, giving it the right variable, the right arguments in the constructor, so it's very clear what went wrong to the user. It's always important. Throwing exceptions is good, actually. In many cases, it's important. If you catch all the exceptions possible in your code and the user of your code never gets an exception, that's not always the best practice. So don't catch all of them, especially not like this. When you're catching any type of exception, no matter what happened, we're just catching it, and here we're displaying some message that may or may not be true. So you have to deal with the right exceptions the right way, and in many cases you will catch an exception in your code, and in the catch block you'll just throw your own exception, or you'll just throw the exception that you've received, so that the user of your code will also get notified. So make sure you're catching the right ones, you're handling them in a proper way, and if somebody is using your code wrongly, they will also get the reason for their fail. So could be an example like this, when we are catching some kind of exception, and then we're throwing our own exception with more user-oriented details and message, because the user doesn't care about the database, but it cares about the fact that they send a wrong data to us. Or, for example, if we're trying to insert to a database a date which is too small, and then we'll fail, but actually the cause for this is the user that has to be notified that their data is wrong. Yeah, and always you can bring you can always nest the exceptions with the original one, so if the user gets your exception, they'll also see the original exception that caused the inner exception that actually caused the problem in the first place. Display data to the user that they can understand. In this case, I'm not sure either one of these windows is very well explained. But here we're getting actually the exception with all the call stack details of the fail, and here we're getting a very laconic message saying Internet Explorer encountered a problem, which we don't really know what went wrong, but let's say that many of the users won't really care what went wrong here. They cannot understand that some boundary was out of index or memory is run down. They can't really do much about it. So this message might be better to give to the user that we caught some problem. Disposable resources like stream readers, it's better to put in a using block where it's clear where we're using them and when we're disposing them. In many cases we've seen such examples, and I think this is a very common way to use them, and I think also a good practice. And of course, in many cases, we'll have try-catch blocks or try-finally, so that we are properly disposing, closing. In any case, it's always good to make sure that your, in this example, a stream reader is closed properly. If we're using a using block like this, it will close once the code is exiting. In other cases, we always go to the finally block in the end and closing it. So make sure that you're controlling your disposable resources. Don't keep memory leaks of things that are not properly handled. Okay?
After the catch block, if we catch an exception and throw it, it's a method. Are we executing the conditions and everything after that? We have a method, it's parsing something.
Yeah.
We have try-catch block.
Mm-hmm.
And after this try-catch block, we have some other actions. Okay, our method is throwing an exception because it could be saying try-catch.
Yeah.
Are we executing the other part after?
Once you throw an exception, your execution doesn't continue from that point.
I'm sure because I think more going like that. When I only try to catch all the exceptions and call down the
If you are catching no example, where's the example? Okay, here we have a try-catch block. We caught some exception. We are handling it here. After we're done with this, the execution will continue. Yeah, that the idea of a try-catch. If your program encounters an unhandled exception, that means out of memory, null reference, object is not reference of a type, things, any kind of exception which is not handled by your code, this exception will go up and up and up to the operating system, and your program will be shut down in a ugly window that there's been some problem. If you handle the exception with a catch block, do what you do, display an error message, whatever you need to do. After that, you are gracefully handling the exception and continuing. If you at any point throw an exception, for example, I caught an exception here, and then I threw my own exception, then I'm out. It's as if the program threw some exception. If I get here, I throw, unless somebody at a higher level of the calling stack catches this, it will go all the way to the operating system and crash.
So throwing means that we are not executing the other stuff.
Once you throw, you are thrown out of your method, and whoever called you will also receive the exception. If they don't have a catch block, it will go to the caller. If they don't have a catch block, it will go to the caller. And it will go all the way to your main method, and it will go all the way to your application runtime in the operating system, and it will crash your application if nobody catches it.
So we don't need to catch the exception in everywhere. We just get the catch in the main.
Well, no. You have to handle the exceptions close to where they happen and relevant context to where they happen. If you're handling a file and you're expecting some crash related to the file, you better catch it over there, not in your main application. I mean, you could have 20 layers of methods calling each other in classes and hierarchies, and somebody threw an exception somewhere on the way, and you're just catching it on your main code. File not found, somewhere along the way. You better keep them tight to where they are needed. But if you caught something and this, for example, is not interesting to the user of the current method, that some database error has occurred. The problem is that they send the wrong data. So you better throw the right exception to them, notifying that exactly what went wrong. I can tell you, for example, that Sitefinity is a web-based application. It uses ASP.NET mostly as the user interface. You don't just throw exceptions because those exceptions will end up on the client and it will be very nasty. So whenever we have some exception, we either display a alert box or we display a nice error message on the client side. But usually we throw exceptions on a very well-defined scenarios, and those exceptions will usually have a very well explained text saying exactly what went wrong. It could be that the user put a 0 where they shouldn't and they click the button. Then we'll say, actually, you had a mistake here. But it will go, if it has to go all the way to the server will try to process it, will throw an exception, it will go all the way down, but somebody has to handle it not to completely crash. So
You are not handling it in every method,
you're handling it where it's supposed to be, and also in the context of where it is. So if the database handler has a problem, it will be the one throwing the exception. Or if some other class that we are implementing has a problem, it will be the one. If it's a web service that we're trying to call and has a specific problem, it will be the one throwing the exception. In the end, it will all reach to the client, and it will handle it in some uniform way, let's say. But the throwing has to be relevant to your case, to your context, to your class, to your method. And also, of course, use the right types of exception, give the right messages, be logical also about exceptions. Yeah, documentation, another fun part of developers. Like I said on the seminar, good code doesn't need documentation. It was hard to write, let it be hard to read also. Of course, we're always mentioning how your code has to be readable and simple to the reader, to the user, to whoever debugs it. Keep it simple, keep it well structured, keep the names right, keep the variable names right, so that your code is self-documenting. Of course, code does need, I think code always needs comments, but you don't need really to comment every single piece of your code. In many cases, if the code is well written, if you have a method, it's important to document what this method is for, what's it using, and what's the variables, what the arguments are for, and what is the expected return value. So I think we've also seen that if we have some kind of class with a nice name like this, if I have a method, for example, excuse me for not putting it into separate variable, but when we are writing a new method, oh, why am I getting this? Just a minute. Let me stop. What? Where is this coming from? Okay, we'll do it the old-fashioned way. Return this. There is an extension which I like using, which documents the code. Actually, maybe I can do it with a right-click. Yeah. So these kinds of comments are very important, I think. This extension is trying to guess what my method is trying to do by the name. So if it's a sum, then it sums the something. But this is wrong. I would write something like calculate the sum of A and B, for example, so that whoever comes to use this method, if I have some other method here which is using it, I'll get the documentation here, so that whoever comes to use this method will get the right way of using it. So that the fact that it says it here A, so we can say first operand the sum and, for example, so when I put here the variables, I'll also get the explanation of what they're for, each one of them, which makes my code much easier to use. So this kind of comments is of course important. Putting a comment here would be a bit too much, and you don't need to start over documenting your code. You just have to make sure that it's readable enough and user-friendly enough to whoever comes to use it.
What is the name of the extension that we use to document the code?
Ghost doc. Here it is. Named after the movie Ghost Dog, which is a good one, by the way. So yeah, of course, the best documentation is the code itself. If you can speak fluent C#, it's best. But some pieces of the code need documentation, especially if you are making changes in existing code, or if you're putting non-trivial handling. Whenever I fix something, I usually put a comment there to say what's going on there and why. So If you have bad code, documenting it won't do you much good. You better rewrite it in a better way. So
Comments and codes that if you change something and to keep the old version.
usually not unless you have a good. If you're making changes and you're keeping the old code commented out, it's usually on some kind of temporary fix that you're keeping it to see what was there and what you've changed. But otherwise, it's not a good idea to keep old code commented like that. It could be confusing. Oh, but actually, why is it there? Why is it commented? Ah, this code is here. It looks like it should be working. Why is it now commented out? I don't know. Who did it? I don't know. So, yeah, not good practice, unless you have a good reason. Everything I said and everything you learn about high quality code comes to the point unless you have a good reason to do it differently. Yes. Rules are meant to be broken. So here are very, very, very bad code. Not bad code, badly documented. So nobody coming to read this part, this line, needs to know that it's creating a new list of integers, because let's say that if you need this comment, then you're in the wrong place. So you don't need to put comments on every line, especially not if it explains, just denotes what the code is doing literally. You can write here, we're preparing a list of integers for this and that, or this represents something, or this is here for some reason, but saying what it is a bit silly, I think. Perform a loop from start to end. So it would be better to say scanning the array of this and that between the range so that we can do something. If you really have to document your code, if you have a feeling that this could be well explained in a comment, then it's good, but don't write such comments. I have no idea why this thing is here. Maybe I should have read the code. This is quite obscene. So here's the code, much simple and neat, easy to read, well structured, simple.
Actually, the previous one told you because you know that this code is like this.
Yeah, but if I see a code like this, if I see a line like this with a comment like this, I think it's not a good. Again, it's good to keep comments where you think that they are necessary. And in some cases, they are important. You cannot always have code that looks like this, small and neat, and does the one little loop, and that's it. This is very rare to see in many cases. But if you have to start explaining in a way that you are writing literally what is happening, it's I don't think this is useful. I think this is just taking lines, and this can be confusing because this has no intention, and if somebody starts reading it for some reason, it's just a waste of time and doesn't really help much. I mean, if you change something, yes. If you make changes which are not trivial, of why actually this is here, or this was written differently, but I decided to change it to something else, and I have to say why. So yes, of course. Then you have. It could be reviewed as a bug. I mean, bad documentation in the code is some kind of bug because it's misleading in many ways to what it's actually doing. There is, I don't remember this old joke about about a man in a flying hot air balloon, and he's asking, he gets lost and he asks someone, "Where am I?" And he says, you're in a flying balloon." And then he said, "Oh, you must be a consultant, because you gave me information that I already know. You didn't give me, you're saying something which is right, which everybody knows that it's right, but you didn't really give me any useful thing to work." And then he said, "Oh yeah, you must be a manager." And he says, "How?" "Well, I actually gave you the right information. You're still in the same situation that you were, in the same problem, but somehow it's my fault now." So, if you want to explain what is this, and you say, "Well, this is a list of integers," and it's really just like saying, "Well, you are here." Yeah. Of course, in many cases, you'll get to such code, and even if it will look like this, it will not be fully understandable why it's here, what is the purpose of this loop, or whenever you think it's not clear enough, document it, but keep your code as clean and self-explained as possible. Yeah, we know all that. So here we have to maybe give a clue of what's going on, for example. Well, refactoring is the endless task of in improving the code and making it more to the demands, more to the specifications, more to the requirements, more decoupled, better written, improving the structure, improving naming, improving everything that we've been discussing, trying to make the code better. And as I was talking during the break about the fact that this is a part of life in many cases, especially in big projects. You're trying to make it as the best as you can, and of course every developer have their own style, and the big project is made of many parts and many sub-projects and many classes and many assemblies, and many times you're trying to do it the best you can, and then someone comes and says, "Oh, but actually we need this and that feature," and it starts breaking your class into something that you haven't planned, because you were planning that your class will behave in one way, but now you need additional functionality which you didn't count. And in many cases you will have to start refactoring your code, just in many cases keeping your code intact in the same way that it was, but just breaking it down differently so you can inject changes in the right places, or making it better. And actually in this process you are making it more decoupled, more broken down. So this is part of, like it says here, making the good code better. Well, making the bad code good and making the good code better. Bad smells don't always indicate bad code. Sometimes you just need to open the window. But yeah, refactoring, if you see code which is recurring in different places, you can wrap them in external methods. You can split methods, you can put, all the aspects that were discussed in the previous lecture about higher quality code and today are valid for refactoring and making it better. So if we're talking about cohesion split into smaller pieces that are more self-aware of exactly the task that they are supposed to. Coupling means make them as decoupled as possible. If you need, you can make helper classes, external classes. Make sure that your class hierarchy and design and references between classes is as best as we can, as best as it can be. Avoid coupling again. If you have methods from one class, just make sure that they are moved into the right encapsulated area of your code. If you have to, well, many times you have two classes which are really tightly coupled, and that sometimes suggests that these classes may be merged into a single class, although many times this is I mean, also depends on the context of the data, and if these classes are so close to each other, maybe they do need to be merged, but many times they have implementations which depend on each other, and sometimes you have high coupling that you cannot lower. But again, this depends on the case. Privacy and access modifications, everything that we discussed about constants and putting the right places, putting better names to classes, splitting very tough to understand expressions like we saw. In many cases, it's a lot of splitting into smaller pieces, putting them in the right place, removing unused blocks, unused code. I don't think there's much of more that we haven't repeated many times already. Well, of course, if your code is not using if it is not using the right error handling or the right bad cases, add some defensive programming, improve error messages, use unused using definitions. Again, one of our plugins for Visual Studio, which is called Just Code, which is developed here in Telerik, is one gives nice references to where you're using variables which are never used, methods that are never called, using statements which are at the top of a class which are never used. So, for example, I can say this class is never called anywhere, or if I create some variable, I can see that this one is never used. Or if I have on my class some using statement that I don't use, for example, reflection is never used, it will also mark it for me. So this helps. Of course, it's better not to keep things that are not in use. We'll see a live demo in a minute. There are some resources here. There is a high-quality programming codes course, which can be has some references and some materials. And there is this book, Code Complete, which is very famous and very widely used, which gives all the conventions and all the rules and all the things that are whatever you need to know about high-quality code and about code in general, which is considered a very good book. We'll be looking at a small example of code that is not the best code written. First of all, have you seen it? Have you seen this task? Have you seen the demos of today's? So the task here is to produce some kind of a matrix scanner, which starts from the upper right corner and then scans the cells of the two-dimensional matrix by a specific rule of scan. And since it's already 9 o'clock and I wanted to make it a more interactive part of looking at this code and seeing what you think and how you think, and giving some ideas of how bad it is and some things that we've seen that can be quite improved. So for example, this whole code is put in one class. This whole project contains one class. The comments here, to my horror, are in Bulgarian. So I spoke to the guys in the academy and they said, "Oh, let your students translate them for you."
But there is smiley text. Smiley text, there is also subtext. This is important. You should keep them. But I think it's nice to keep them.
Yes, get a good.
Even if the client sees your code, he will be, for example, he will need to see your code that he has a problem. But if he sees in the commands the smiley faces, then he will tell you.
Yeah, it's true. So we have a commented out part here. This is our main program. It's a console application as usual. We have some commented part here which takes the data from the user. Otherwise we have some hard-coded code that makes the matrix on hard-coded value. So what does it say actually?
It's a little bit better than
Huh?
It says it's a little.
No, it says the definition task is sucks, but break works as 100%.
it says this condition is bad,
This condition
but
is
there
bad.
is a break which works.
But break works. This condition is not broken.
But the interesting thing is that you can read this code. You know what this code is doing, so it's not so bad.
Okay, but let's discuss some things. First of all, I don't think naming methods in Bulgarian is.
But do you understand what is written and what this code is doing?
I understand what this code is doing, but you have to agree with me that this that it can have a number of improvements at least.
Understand what the code is doing, we only understand the comments.
So we complete each other.
The difference between the nature and the...
So the first thing is, well, we're not going to go line for line here because it's really going to be torture. But we can see that we're holding a matrix here, which will be our main scannable matrix according to the rules given by this well-explained task. Apart from that, we have a number of variables here that we can see, which, I mean, starting from here already we can see some signs of bad coding. For example, we have a bad naming of a variable. By the way, one of the benefits of this extension, which I was mentioning, which is the Telerik extension just code, when I have a variable name that I need to rename, there is a shortcut that I can rename. For example, I can rename it to, it will rename it everywhere without search and replace. So So things like that. Give your variables self-explanatory names. And we have many of those here which are not really understandable why they're here. We have some kind of scanning done here, so we're using those I and J in the matrix, and we're setting a value of K. So these things this code is really, really badly written. If we start putting it more in structure, look at this line. How can you debug such a thing? I mean, the structure here is bad, very bad. I mean, if we start breaking it down into what we could do with it. What is that?
If you're
yeah. I mean, I think that they did a very good job here trying to show bad example of code. And they really worked hard on that.
Manual obfuscating. Manual obfuscating.
Yes.
Challenging. The Visual Studio built-in format to format.
Yes, you can. Not that I remember.
Control F, I think, was the shortcut.
What's the shortcut?
Control K, Control F.
Control K, Control F. It's somewhere. Format document. Nice. So it's already a bit more readable, and now we can also start seeing some structures here. We have a for with an if, and here we have the if block inside, which is completely not readable, and this break statement is a separate statement, and this if is inside the for, so it's actually much more clear, and we have too many nestings here going on. And this whole class, this whole handling of this matrix could be maybe, let's say, put in a separate class that handles all the matrix methodologies of what we need to do. So this matrix could be quite self-contained in itself, but we're creating it in the main, and then we start working on it, and then we're calling methods. And the usage of X, Y, I, J, K is completely all over the code. It's impossible to know what's really going on. And as much as I understand now, the comments are not really helpful. So you can look at this example, and I think that it could be a project from some exam that somebody wrote. By the way, starting from the namespace, it's already.
But it's harder to change it's too hard to change the namespace. Then you have to change the folder and things like.
Yeah, but that's something you should have thought in advance. Otherwise, you really. I mean, it's possible to change namespaces, class names, even though they don't match the file, and in many cases. By the way, this comment that I'm getting here in the green is that the class name doesn't match the file name, which is also coming from this same extension plugin. So, which is also something which is to be kept. Like we've seen, when I add a new class to my project, it will by default give the class name and the file name. So also the structure of the files and the names of the files and the folder structure of your project is something to consider. It's part of your good code. It's not just the names of the classes, methods, variables, arguments. It's all in one. When someone opens a project with 20 files, or when someone opens a solution with 20 projects, start finding where you are, what is this for, What's the reason of this code being here is important. And now we're going to walk through one line at a time and fix this code, or not. There's obviously a lot of work. Yeah, this part. Weird.
Are you refactoring some other guys in other programs to develop this code, or they are refactoring themselves? In your code, you're writing the note and they're going to do it, or you're doing it?
That depends. In the everyday work on a very big project, it really depends. Refactoring is part of the developer's life, and even though many developers are very good ones and they follow all the rules, and like we said, oh, we need something which we didn't think about, or we need to extend some functionality which never existed before, and then we have to start refactoring. Or some code is written in a way that then we review it, even though it could be old code, and then we say, actually, to suit better our new code, we will have to refactor it to work in a better way, so that we don't call this method 300 times, but we actually use an external class to handle this. So it's customary for, I mean, when you have such a big project, it's usually you worked on in certain areas. So certain areas of the project are yours, and you know them better, and you can refactor them better. But many times you'll refactor someone else's code, and many times you will debug someone else's code, and you'll review someone else's code. And yeah, the best scenario is that you will refactor what you know and what you've been working on, but in most cases it's not the case.
There is a history with related changes?
Yes. Yes, there is a history, and sometimes you'll see a change in a code and you don't know why it's there or who did it and what's the reason for that, and you can go back and annotate who did it, and then you can call the person if he still works for the company. And no, this is real. I mean, even in the past few days, I can give an example that we've seen some changes of people who've already left the company some time ago, but yeah, you have to start trying to understand what they did there and how and why. So this is the wild, I mean, it's the open, wild, unknown, uncharted territory, and try to keep the rules, not always working. You'll need to refactor many times. It's not your code, but still. So make it easy for the people to come to read what you're doing.
There is an option where one is working on his own style, and then he's doing what he likes.
Yeah, but that's yes, yes, of course. But these rules should be kept as guidelines, and of course, things like naming conventions and how you structure your class are standards, and they should follow the standards of the company, the standards of the team that you're working on. So there are infinite ways to do it, but try to do the best you can. Of course, anyone can do it differently, and there's always creativity in programming, but keeping those rules is something basic that you have to stick to as much as you can. But even though you stick to them, there will be always someone who thinks, oh, actually this could be better, maybe like this, and maybe they're right. Or maybe you have a reason to think that actually many times my team leader came to my code and said, well, I don't really like the way that this is written. But I said, yeah, but we have to do it like that because I know it's ugly, but that's the best way we can do it right now because of restrictions A, B, C, D, because we have to do it. because that's the best way currently. And that's also a fact of life many times.
Can you point some rules you are following in your projects? Some other rules of this?
Apart from all this, no. There are rules which are more specific to their company company conventions.
Not about your personal.
These are basically the most common rules that I can't think of any more right now. I keep my code in regions usually.
You are one of these guys.
I'm one of these guys. And actually, I think that using regions makes especially big classes to be more readable, and it's actually a convention in our team at least to put regions in the code. So you have, for example, the public methods. And when you come to the class and you see this, you will know that this region contains the public methods. Or here I put the, for example, so I know that in this section, why? I know that in this section I'll have the interface members. So cutting them like this into structured pieces of your class. Of course, many times the first thing I do to a class when I open it is open here and do the outlining, toggle all outlining, and I open all the sections at once so I can see the whole class and I can scroll through it. But sometimes it's more comfortable to know that I'm looking for some public or a constructor, so it will be in the constructor region. So it gives more readable structure internally of your class.
But not master.
It's not recommended, although I have to say that sometimes I use nested regions if it's something which is very huge part and even inside a method which is big and has different sections, sometimes it's used. Although not recommended. So you didn't hear it from me. This is on the record, so I never do it.
Is there a way of an extension to Visual Studio that we could use to collapse formulas, if statements, or something that which is wrong to be bigger than a few lines, but sometimes happens? Is there, especially in such cases where we are refactoring some other code, someone else code?
I don't know of such extension.
I know JavaScript there is.
Mm-hmm.
I haven't seen such thing for C#.
No, I don't know of such. I know that it gives me the pieces here, the code blocks, connecting which is which, with colored lines, but I don't know about collapsibles. Methods, classes, and namespaces.
You can have a few namespaces in one class.
Yes,
That is wrong.
yes.
Really wrong.
It's wrong in so many levels. More.
For example, when you are using, for example, one class, then somebody else is working in the same class at the same time.
The answer is yes. So what happens?
What happens is, is it a big problem and is there some issues with it?
Well,
And some rules.
well, there are no rules here. We're using a source control which is a common thing to use when you have multiple people working on the same project. So in the old times, not so old times, I've been working until, let's say, something like 5-6 years ago. I've been working with source control, which was common for Microsoft as part of Visual Studio, which was called SourceSafe. And SourceSafe was very commonly used. It was an external application that also, of course, integrates into Visual Studio. And the nice thing about SourceSafe is that only a single person can edit a file at one time. So the files are checked in on the server. When you want to make a change, you check out the file, you open it for editing, and from that moment you're the only one who can edit the file. You're done making changes, you have to check it in, so everybody else gets the updated file. And that's nice because it keeps exclusive work. So if you're working on something and I can see you're working on this file, I can come to you and say, you have to, I want to work on this file too. And then came a newer system called Team File Server, Team Foundation Server, yeah, TFS, which we're using now, which is commonly used, which allows multiple users to work on the same file at the same time. And that's okay as long as they work on separate areas of the file. If they change different areas, different lines, that's okay. Once they work on the same region of the file, there can become a conflict. So the first one to check in the changes, he is clear and he's okay. So I saw once, you know, those XKCD cartoons, very funny, geeky jokes. So you see two programmers and two desks, and one says to the other, "Can you come here for a second?" So he comes, "Hey, what's up?" Said, "No, nothing. I just wanted to be the first one to check in the file." So once you are the first one, then you're okay. Then the second one who checks in, if he made changes on the same lines, there'll be a conflict. And then you have to do some smart merging. You have to go to the changes, usually with the person who made previous changes, and see which lines are to keep and why. So you have to do some little surgical work. It happens, yes.
But with the older approach, you know, someone has checked out the document and forgot to check in, and you want to access it somehow.
Yes, binary files are locked. Once they're checked out, they're locked, and you cannot override.
It's on vacation for 2 weeks.
Yeah, actually, this is an example from today, because, well, we're working on multiple branches of the codes because we have so many versions, and now we've released version 5, but now we're starting to work on version 5 hotfix 1. So we have multiple branches of the code which contains the whole code in different states. And many times when you make some change in one branch, you want to merge your changes to another branch. And today I was performing such a merge. And then we found out that some old files in this branch, which haven't been used in a long time, are conflicting and they are locked. Some document files. And some of them were locked by someone who doesn't work in the company anymore. And some of them were locked by some Indian guy who works in the States, in the opposite time zones. So the files for the person who doesn't work anymore in the company, we just forcefully reverted. And for the other files, just sent an email, please check in your changes or undo, or there are
always a clear system for subversion using, because there are different types, and for them, for example, when you check out, the file is not locked, and until you have not complete with the file that is in the server, you can check in anytime, and it's not any restrictions who will check in first, but the next person will make a conflict and then have to merge.
Yeah, I didn't like the whole idea of multiple people working on a file at first, and now I still don't like it. But But it helps. It's more productive when more people can do work at the same time. But we are a bit diverting from.
Also, there is a plugin for it that allows at least two persons to write over the same file at the same time, so they can see two cursors.
Only sick minds, like people using Eclipse and Linux can think about such. Java, Linux, Eclipse.
It's in Google Docs also.
Is it still? I thought it was only in Google Wave, and I think they
No, it's in Google Docs.
so you can see the changes in real time.
It's even better if they are 10%.
You see people and they have a different color selection where they could select those questions.
I'm interested in how they make that.
Well, yeah. It's hard, especially on a web system. Any more questions and things about? Okay, in that case, we're done.